Section 3.6 is the chain rule. Pretty exciting rule. It is very powerful. So far we've been just looking at fairly simple functions. Now we're going to be able to look at functions inside of functions. Note that if I would have asked you before today, if I asked you to take the derivative of this particular function, what you would have to do is multiply it completely out. You'd have to take 5x plus 4 times 5x plus 4 times 5x plus 4, multiply it completely out, and then take the derivative term by term. With the chain rule, that's going to allow you to take this derivative rather quickly, and you will appreciate it, but it takes a little bit to get the hang of it. Now, they give you two versions of the chain rule, and I'll go through both of them. We start off with the theorem and how to use that theorem, and at the very end we will do the proof of the theorem. So at the end of this video, look forward to the proof. On the chain rule, you're going to have to identify an inside and an outside function. In version 1, your u is your inside function. In version 2, g of x will be your inside function. Now they're both the exact same thing, it's just two different ways of looking at it. I don't care which method that you use, just be sure and look at things as the inside function and the outside function. Some people like to look at this version 1 and other people prefer version 2. My preference is version 2, but we should be able to use whichever one. I would like to find y prime. The first thing that I need to do is identify what my u is, and in this case the inside function is this 5x plus 4. So if I do a rewrite on this, I would get y equals u to the third. And what version 1 tells me to do, it says take the derivative of y with respect to u, multiply that by the derivative of u with respect to x. So let's play that game. Y prime equals, I'm going to take the derivative of y with respect to u. That's going to be 3u squared. Then I will take the derivative of u with respect to x, and I will multiply those two. So the derivative with u with respect to x is a 5. So far I get y prime equals 15 u squared. Now I don't want this thing in terms of u, so let's put it back in terms of x. 15 and u was 5x plus 4, and that will be quantity squared. Now isn't that pretty? On this one, I could have written this as y equals sine x quantity cubed. I usually write the 3 on the sign just because it's easier to write down. I don't have to use parentheses, and it makes my life a little easier. But this is what it really means. And if I write it like this, I can identify easily that inside function. And that inside function will be sine x. And then y can be rewritten as y equals u to the third. So I'm going to play this same game. Y prime is, take the derivative of y with respect to u. That's 3u squared times the derivative of u, which is, with respect to x, which is cosine x. Next I'll replace my u with what it really is in terms of x, and that would be sine x quantity squared. I want to write it in my neat little shorthand way because it just pleases me so much. Sine squared x cosine x, and that's how I would write b. The next one, I have x being cubed. In this case, my u what's on the inside is x cubed. In this way, I can look at y equal the sine of u, because I have a theorem that tells me what the derivative of sine x is, but I don't have a theorem that tells me what the derivative of sine x cubed is. But with the chain rule, I'll be able to find that out. So y prime equals, I'm going to take the derivative of sine with respect to u, and that would be cosine u, and then I'm going to multiply that times the derivative of u, which would then be 2x squared. Replacing my u with what it means in terms of x, I'm going to pull this 2x squared out front because I don't like it back there at the back. I don't want it to get confused and thinking it's in there with that cosine. The cosine of u is x cubed. And there would be the answer to C. Alright, we're going to use version 2. It is exactly the same thing, but just written in a different way. In this form, I recognize my outside function and I call it f. So my f in this case is going to be, the outside is going to be x to the 10th. My inside function, he's usually the easiest to identify first, is 6x cubed plus 3x plus 1. This tells me I can get the derivative by taking this derivative of this function inside a function, by taking the derivative of the outside, that's what this says, take the derivative of the outside, leave the inside alone, times the derivative of the inside, which is exactly what this did. This forced you to leave the inside alone. So I am going to, these are the x to the 10th is my f, and there's my g of x. So I'm going to do derivative of this f of g of x. I think I'm just going to call it h from now on. Okay, I'm going to take the derivative of the outside. So the derivative of the outside, this x to the 10th, is 10. Leave the inside alone. So there's the derivative of that outside, or that f function. I'm going to leave the inside alone. So what goes on the inside is 6x cubed plus 3x plus 1 times the derivative of the inside. The derivative of the inside, here's the inside function, 18 x squared plus 3. Let's see, I guess I could pull the 3 out of there. I could make it a little prettier, not a whole lot. Pull the 3 out, that would make it a 30. 6x cubed plus 3x plus 1 all to the 9th times, after I pulled that 3 out, this is 6x squared plus 1. And that's as pretty as that one gets. This one I would rewrite as 5x squared plus 1 to the 1/2 power. And I'm going to call it h of x. I'm going to just say equals h of x. So h prime of x is going to be, now here's my inside function, this 5x squared plus 1. I'm not going to write it down. The outside function is the 1/2, that thing to the 1/2 power. So I'm going to take the derivative of the outside, which is 1/2, leave the inside alone, subtract 1 off of that power. So I'm going to leave the inside alone here. That was 5x squared plus 1 times the derivative of the inside, and the derivative of the inside is 10x. And that's it, because the 1 drops there. This is to the negative 1/2 power, so I'd like to leave my answer in the same terms that I was given. I have the 10x, he'll be on top. I'll have the 2, the 1/2 will be sitting here, so I'm just going to write the 2. You could put the 1 up there if you want to, but and this will be square root of 5x squared plus 1. this guy, I guess I'll cancel, and I'll get 5x over square root of 5x squared plus 1. Okay, next one. Oh, let's see. We're going to say that this is h of x, and I need to find, let me do this here. I need to find h prime of x. In this one, my outside function is something to the third. This whole whopping thing is my inside function. So this whole thing is my inside function. So I'm going to take the derivative of the outside, leave the inside alone. So that's 3 times, oh, that's with respect to t. Sorry about that, h of t. H prime of t. Hold on, I'll fix it. Okay, that looks better now. So leave the inside alone, 5t squared all over 3t squared plus 2 to the second power, because now I took the derivative of the outside, because that's 3 with the whatever to the second power. Now I need to take the derivative of the inside. The derivative of the inside involves the lovely quotient rule. Thank you so much. So it's going to be low d high. So that is 3t squared plus 2. Derivative of the high one is 10t minus high 5t squared times the derivative of the low one. Low one is 6t. Stunning. All over 3t squared plus 2 quantity squared. Oh, that's just lovely. So try to clean this up a little bit. 5t squared over, you're going to stay like you are for a while, little bud. And then I'm going to mess around with this guy. And this is 3t squared plus 2 quantity squared. Multiplying here, that's going to be 30t cubed plus 20t minus, and that would be 30t cubed. What a coincidence. Looks like these terms are going to cancel, and I could probably write this as 3 so that I can kind of combine that denominator. I'm just going to do 3t squared plus 2 quantity to the third, and you're going to be 25, because I'm just going to go ahead and square this top term, and that's going to be 25t to the fourth. And then all I've got left here is 20t, so it's times 20t. Oh, I just saw that that was at the second, he's at the second. This is actually to the fourth. Sorry about that. Then this is going to be 60 times that, 60 times the 25, that'll be 1500 t to the fifth. I need more room. All over 3t squared plus 2 to the fourth. That one was messy. But you can see that whichever version that you're using, it's still the derivative of the outside, leave the inside alone, times the derivative of the inside. If you'll just say that over and over to yourself, then you pick your inside, you pick your outside, and once again that's the derivative of the outside, leave the inside alone, times the derivative of the inside. Next, we've got a table. We don't get a function, but we're supposed to calculate h prime. So h prime of x is going to be, take the derivative of the outside, f happens to be the outside in this case, leave the inside alone, times the derivative of the inside. So if I need to find h prime of 1, that's going to be f prime of g of 1 times g prime of 1. Substituting in f prime of g of 1, that is g of 1 is right here, that's a 2, times g prime of 1, g prime of 1, that's 3 from right there, f prime of 2, f prime of 2, that's a 7, times 3 equals 21. Play again with a 2. h prime of 2 equals f prime of g of 2, g prime of 2, f prime of g of 2, g of 2 is a 1, times g prime of 2, g prime of 2 is a 4, and then I need f prime of 1, f prime of 1 is a 5, 5 times 4 equals 20. They make a distinction here over the chain rule of powers, but you don't really need it. It's the same thing that you have been doing. If I look at this as being my inside function to the 21st is my outside function, what I'll do is take the derivative of the outside, that will be 21 times, leave the inside alone, you'll be to the 20th, and this will be tangent x plus 10 because I'm leaving the inside alone, times the derivative of the inside, and the derivative of tangent x is secant squared x, and the 10 is a 0, so he's gone. So maybe clean this up, make it 21 secant squared x so that he'll be up there in front. And you might do this, tangent x plus 10 to the 20th. No real need for a specific chain rule for powers, but we can make one. Alright, these things can get really messy. So we'll just call this f of x. So f prime of x. This is a function inside a function inside a function. So just keep track of what's your inside and what's your outside. I'm going to have this entire wad of stuff be my inside function. So I'm going to take the derivative of the outside, derivative of a sine is cosine, leave the inside alone, so that's going to be the cosine of e to the cosine x, and this is going to be times the derivative of the inside. Now the inside is e to the cosine x, so I need to take the derivative of that, but I have another inside and outside function where this time the cosine is the inside function. So I'll take the derivative of the outside, that will be e, leave the inside alone, times the derivative of the inside, and the derivative of the inside is negative sine x. So this one is really messy. I'll clean it up a little bit. So I'll write it as minus e to the cosine x times the sine of x times cosine of e to the cosine x. Lovely. What I'm going to want to do on this next one is, of course, rewrite it to the 1/2 power. So I'm going to rewrite, I'm taking the derivative with respect to x of x squared times x squared plus 1 to the 1/2 power. Okay, let's see what I've got. I see that I have first and foremost product rule. Here it is. I have this thing times that thing. Do you see them? So what I'm going to do with the product rule, take the derivative of the first, leave the second one alone, add to that the first one times the derivative of the second one, and that has the chain rule in it, where this is the inside function and something to the 1/2 is my outside function. So I'm going to take the derivative of my outside function, leave the inside alone. So the inside is x squared plus 1 times the derivative of my inside, which is 2x. Now I see what I have with this big old whopping mess. So I have 2x square root of x squared plus 1 plus, okay, let's see, I've got a little canceling. This 2 is going to cancel with that 2. So it looks like I'll have x cubed over square root of x squared plus 1. Now I can go ahead and let you know that the mathematicians aren't really going to like these two terms sitting here just kind of lonely. What they're going to want you to do is combine them into one chunk or combine them into one fraction. How you can do that is you've got to get the same denominator. Now we can say that he's over 1. I'm going to multiply top and bottom of this first guy here by an x squared plus 1, square root of x squared plus 1. And then I'll just manipulate whatever's going on here. Let's see. So I'll have 2x times, and these have exactly the same base, so the power would be 1/2 plus 1/2, which is 1. So that's what I'll have in the numerator, and that does look nice. I have x squared plus 1 in the denominator plus x cubed over square root of x squared plus 1 down here. Keep the same denominator and just add the tops. That would be x squared plus 1. And I have 2x cubed here and 1x cubed here, so that's going to be 3x cubed. Plus, distributing that, 2x. All done with that one. Now we have the proof. Alright, we're going to let h of x equal this f of g of x, where f is differentiable at g of a, and g is differentiable at a. I'm going to use the definition of the derivative and say, so use of derivative. Remember there were several. I'm going to use the one involving in the a. H prime of a equals the limit as x goes to a of h of x minus h of a all over x minus a. Now I'd like to replace this with my f's and my g's, so the limit as x goes to a of f of g of x minus f of g of a, and this is all over x minus a. Now what I'm going to do next is what we call put in a chicken, take out a chicken. No, it's actually now I'm just going to multiply top and bottom by some chickens. But it's something that I'm going to need, and it's pretty contrived. I know that I'll need this. So I'm going to multiply top and bottom by the same thing. Now this is provided that g of a is not equal to g of x, but it can be extended. This proof can be extended if it happens to be, but this is just the shorthand version of the proof. What I'll do now is kind of swap the positions of these two guys because they're both being multiplied, and so that's what I'm going to do. Limit as x goes to a of f of g of x minus f of g of a over g of x minus g of a times, and then I'll leave this guy here, and I'll just put him over this x minus a. And now what I have, magically, this guy right here happens to be f prime with the g of x left alone. And this guy happens to be g prime of x by definition. And there you have it, the chain rule. It's a good thing we don't have to do that every time we go to work a chain rule problem. Alright, if you have any questions about the chain rule, I hope you'll email me or see me at the Collaborate.